knew it. It's impossible to stop notifications. What do I do about that?
To stop what?
Notifications. It's just impossible.
Oh, you can, if you're running a Mac, I think you can change your focus settings to do not disturb. I usually do that.
And we're live on YouTube as well.
Hello, everyone. Welcome to another riveting episode of Effect Office Hours. All the effect enjoyers in the chat. Hello, hello. We're joined today by Sam from Alchemy, which we're very excited about because Mattia and I sort of chatted about it the last time we were on Office Hours, but we didn't really do a deep dive. So I'm personally super excited about all the work that Sam is doing because my background is in DevOps, and he's solving all the problems that I had in my previous job and my job before that. And yeah, I'm just really excited to hear everything about that Sam's been working on. So yeah, Sam, why don't you introduce yourself real quick, and we can sort of go from there.
Yeah, sure. So I'm trying to figure out how to close my notifications actually, because I feel like it's just going to ping constantly.
The do not disturb thing works well for me, but I don't know. It might not. Your mileage may vary.
It's like totally not obvious.
Also, of course, we're joined by Mattia and the man himself, Michael Arnaldi, today. The man that all of you come to see.
Yeah.
I'm the real reason why this format exists.
Yeah, anyway, so yeah, my name is Sam Goodwin. I'm working on a product called Alchemy for the last year or so. It's an infrastructure as code framework in TypeScript. And the original version was all about async TypeScript. And then I became effect pilled, and the V2 is now all about effect. And I've been obsessed probably the last 10 years with infrastructure as code. I've used every tool for the longest time, of starting all the way from CloudFormation, CDK, Pulumi, SST, and I found them all to be lacking and not what I want. So I've been working for the last year or so. I'm building it from the ground up in effect. And I've got a little demo prepared here that I can jump into, or if you want to pause there for a moment, we can.
Yeah, I mean, we can sort of launch into the demo and then we can ask questions and things. I'm sure the chat's going to have questions as well. Well, there's already actually a question in the chat, which we can maybe defer till later, but I think it's also a trolling question.
Yeah.
Because it's coming from I forget how I'm supposed to pronounce this. It's like fifth.
Our troll.
Our own personal troll asking if you can use Effect Cluster with Alchemy, maybe one day.
I'm sure you can deploy that to any ECS or EC2 or whatever you want. Yeah, I focus more on HTTP API and RPC for the moment because I'm more of a serverless junkie. But yeah, no reason why you couldn't. At the bottom, it's just infrastructure as code, right?
And chat, maybe you can let us know also if we need to zoom in or anything like that. But for now, we'll just keep everything the same. And then you folks can let us know if things are too small, if you can't see something, or if you have questions. But yeah, Sam, feel free.
Yeah, all right. So the idea is that, in the world of AI, we really want to start optimizing the whole developer experience, or what I would call the agentic loop, right? I'm calling that zero to production, right? And Effect is probably the best foundation to do that I've found. And Alchemy takes that the next step by bringing in infrastructure and taking you all the way from like a blank screen to a production-ready service with CI/CD, tests, operations, monitoring, alarms, all that, right? So we have done that by rebuilding infrastructure as code from the ground up in TypeScript, or I call native TypeScript, but also native effect. So the whole thing is effect to the bones. You don't have to use effect in your runtime everywhere, but you really should, and I'd like to show why. So the way you get started is we have this little sneaky prompt that you can copy from our landing page. So I'll copy that, and I'm going to just throw that in there. So this is going to be an AI demo, which means I've got some randomness, but like the whole point is that AI should be writing all your code. I started by writing. I was preparing for this and I was writing it by hand. I'm like, what am I doing? It just takes too long. I make all the mistakes. So instead, I'm just going to throw this in AI, and what it will do is it'll create a scaffold and it'll give us our basic stack, which I can start with, and we can start to layer on parts of our infrastructure and our application. So what you'll notice here is we've got a very simple TypeScript project, and we've got one file called Alchemy run.ts, right? And let me know if I need to zoom in, but the core of Alchemy are resources and stacks, right? So this is a stack. You just export default your stack from any file, but we also have a convention that alchemy.run.ts, which is also
it probably is worth zooming in, Sam. I'm sorry to interrupt you. But the chat, it's probably worth zooming in because the chat is notorious for yelling at me about they can't see things.
All right. There you go. Is it zoomed in? That's good. Yeah.
I think it's good. They'll yell if they have any problems.
All right. Okay. So Alchemy run.ts, that's your stack, but you can put stacks in any file. It's just TypeScript. Like we don't say, hey, it must be this file, right? But what you do is you export default this stack, and there's a little bit of boilerplate, and then you have an effect. And then here is where you declare your resources, right? So if you've used Pulumi or CDK, it should look quite familiar, except we got our friendly little yield star. So it's based on effect. This effect will give me a bucket, right? So that's a resource. And then if I deploy this, so if I run Alchemy deploy, we'll see a plan, right? So it loads that stack and it goes, okay, what do we got? We got a bucket and I can deploy it, right? And I'll deploy this to Cloudflare and we see a bucket name pop out. And that's because we're returning the outputs. So you can see that I've got this bucket name output, very similar to Pulumi. This is common in infrastructure as code. It's basically a pure reference to a value that will be resolved at deploy time. So it doesn't exist. You can't get it until after deploy. But you just return those and they print, right? So that's pretty standard infrastructure as code experience. But I'll call out one thing here, which is because it's effect, it's so much easier to plug in your own implementations of resources, right? Compared to Pulumi or CDK, where custom resources are just like a real pain. For us, it's just layers, right? So if I was to come and import layer here and then replace this with layer.empty, we'll get a type error because the provider is missing for the resources that you're trying to deploy. So again, all about feedback for the AI, right? Like as much as we can squeeze into the type system, it's better for AI. It's just going to be able to iterate quicker. And if I get rid of this bucket, you'll see that the error goes away. So it's like it's aware of which resources you're creating, so it knows, hey, you need these layers and you have to provide them. So I put that back and error goes away and I can deploy the stack again. But this is like standard infrastructure as code. I would describe Alchemy, like the core of it is just infrastructure as code. To that question before, you can deploy anything you want. But there's a reason why I also am calling this infrastructure as effects, and I'll show that by putting a worker here. So this is where it goes beyond standard infrastructure as code and into a new layer. So I'll say, set me up a hello world worker that just gets and puts to the bucket. So,
and while that's running, Sam, I have a question. The providers and the state, I'm assuming that the state is like how Alchemy tracks the resources that have or have not been deployed and like what their current state is.
That's right.
And using Cloudflare.state here means that your state file or whatever, however you're storing state exists in Cloudflare, if I'm understanding correctly, right?
Yes. So we automatically deploy a Cloudflare worker, and it's backed by a durable object, and each stack is stored in a durable object. And we do that super fast. It's persistent. If you're already using Cloudflare, you can just drop it in there and it works. But like you can throw in another one. There's local state if you just want to rip locally. There's in-memory state, which I use for tests everywhere. There's AWS state if you want to build your own. It's just layers, right? The whole point is just like take advantage of effect here. You can plug in anything.
And the providers thing here, this is just a layer, which you mentioned. So does that mean that if my stack is using resources from both, like, I don't know, Cloudflare and AWS, that I could compose two sets of providers together?
Yep, just layer.merge all AWS.providers and in you go. Yeah.
Super nice.
And the type system will prompt you the whole way, right? Like depending on how long this demo takes, but if I get to the end, I'll show AWS as well. I'm starting with Cloudflare because I don't know, Cloudflare is just so awesome. Like going back to AWS from Cloudflare is not so fun, but like there's some cool stuff we can do with IAM policies that I'll show at the end. But let me just show what we've created here. You'll notice that it moved the bucket out into a separate file, and it did that because these are just effects, right? I need to reference it elsewhere. They're pure. They don't do anything. I can just put them in a file, and then I can reference them elsewhere. So here we get into what I would call the runtime stuff. So beyond infrastructure as code, Alchemy also allows you to blend runtime logic, which is the implementation of your servers and your jobs, with your infrastructure, and you get it all in one single type safe program. So if it type checks, you know all your infrastructure is correct. And what I'll show here is that we follow this very simple pattern. It should look exactly like layer.effect. You know, you got this a layer.effect tag, and then you got your gen, and then and then you would you pull your dependencies, right? My dep, and then you return your service implementation, right? Like get your dependencies, return the implementation. Alchemy is totally built around this pattern. I love this pattern. This is like all you need to build anything, pretty much. So this is basically a layer for a Cloudflare worker. And in this first step, what we call this is initialization. This is where like resources and bindings go. So you declare your infrastructure dependencies like you would any other sort of effect dependency. So here I need a bind to a bucket. So I call Cloudflare R2 bucket bind, and I get back a client, right? So now I have a way to interact with my bucket, and Alchemy is going to go automatically wire up the infrastructure for this. So if I run deploy, you'll notice that the plan now has a worker, which is a new resource, but that worker has one binding, which is the bucket, right? So you see this in the plan. That's all automated. So like AI really can't screw this up, right? Like it needs to interact with the bucket, so it adds the bind. That automatically figures out the infrastructure, and then it uses it. It's type safe all the way through. And I have this really just contrived example that you can see here. You know, I'm just bringing in the HTTP server request. So it's all integrated with effect platform. So the way you implement HTTP is you just give us an HTTP effect, right? That's an effect that has one requirement, which is the server request, right? And then we integrate with Stream. So we give you a nice effect native interface over Cloudflare, over AWS. Everything gets a purpose-built effect native implementation. So here we can just pass that stream in with the content length, and it works, right? So deploy that. It'll go through, create the worker, upload it, and we should get, I won't go to it yet, but we get our worker, right? I don't want to put something in R2 right now. So what I really want to show is durable objects, which I think are the coolest feature of Cloudflare. So I'll say, let's add a chat.
Don't mention it too many times, otherwise Sunil will materialize himself.
Yeah. That support that uses hibernatable WebSockets. So our docs are all optimized to give you 1 second. Yeah, that's too dark. There we go. Okay, no, terrible. Just realized there's a light shining on my face. Anyway, all right. So our docs are all optimized for Markdown. So when AI is fetching these docs, it's getting the Markdown, and it can crawl the docs, and everything is sort of laid out in a step-by-step workflow that AI can just pull from. So you're getting this sort of interactive experience with any coding agent. So what we'll see here is it's going to create a durable object. So same pattern of export default class. We've got where we initialize our resources. And then we've got an effect that we return. This will run per durable object instance, right? So for those who don't know, a durable object is effectively a JavaScript isolate in Cloudflare's network. And you can have millions of them, and they're guaranteed to be singletons. And you can have long-lived WebSockets on them. And they back to like 10 gigabytes of storage with SQLite. Super powerful primitive. Like you can have swarms of these small little isolates in the cloud all over the world, and just managing WebSockets and managing little bits of state. This is an effect native way to work with durable objects. So we don't have any resources, so we'll just leave this empty. But here you can see that when the durable object instantiate, we'll run this closure, right? So this is going to run per durable object instance, and it's going to set up, basically restore the hibernated WebSockets. And then we'll return our fetch handler. So returning the implementation of the durable object. This is going to just simply upgrade to a WebSocket, right? And I'll also implement the WebSocket message and WebSocket close event handlers. And it's really unfortunate I can't use effect socket here because they're hibernatable. It'd be really cool if this could just be effect socket, but for now, you have to sort of implement it in this decoupled way. You can't pipe off of the socket. But what I'll show next is, I mentioned that it's all about getting to production, right? This is cool. You're deploying stuff. You're building apps, but like I really care mostly about going all the way to the end. So like we really need unit tests next, right? So let's set up a unit test for the WebSocket connection. So Alchemy has some utilities that allow you to write tests that deploy their own isolated infrastructure. So it stands up the infrastructure, runs all the assertions, and then destroys the infrastructure at the end of the test. So this is great for iterating locally. So you get feedback to your AI as quickly as possible of what went wrong at runtime. Like the type system guarantees the infrastructure is correct, then the tests guarantee that the runtime is correct. And then you can iterate really quickly, right? Just say AI, build this feature, iterate till the test pass, right? So let's have a look at the test that it creates. So need to just go fix one little type error. And all right, let's look at the test. You'll notice that I've got this little before all here that has a return value. So the before all takes an effect, and it's going to run that effect before all the stacks and then returning the value. And the value that I get back is an effect. So this is an effect to the properties of my stack. So you can see that I get my URL. And then inside my test, I can just yield that stack, grab the URL for the ephemeral worker that I'm testing against, hit it as many times as I want, and then destroy the stack. And also, if I am running in CI/CD, if I'm running locally, I don't want to always destroy the stack. So you can do this after all skip if, right? So like, hey, I'm running locally, don't destroy the stack, just let me run quickly. So if I run, oh yeah, little bug in our dependencies, unfortunately. If I run the test now, you'll see that it's deploying the infrastructure as part of the tests. And then it'll run some assertions against the test, and then it won't destroy it. I'll make it destroyed on the next run. So cool. We have tests running against real infrastructure that quickly, right? Let's just put the destroy back, see what it does. And then destroys the infrastructure, right? So that's just CI/CD right there. Throw that into GitHub action. Put in a pull request, all the states maintained between different pull request runs. You've got your CI/CD for free with real infrastructure. So that's
and with Alchemy, with this type of test strategy, could you also theoretically set up like local infrastructure if you wanted to, like through like, I don't know, Docker or VMs or whatever you wanted to do? You could theoretically use Alchemy to do all of that infrastructure provisioning as well.
Yeah, infrastructure doesn't need to mean cloud, right? It really just means anything under what I need. It's just like, it's the foundation of what you're running on. Docker Compose is perfectly valid. Even just like, I've got it for like EC2, setting up some like systemd daemons running on an EC2 instance is a perfectly valid use case for infrastructure as code. It's just declarative applications. Yeah.
There was a question in chat that sort of linked into this, which I think the answer is pretty much like what with any, but the question was with what providers can Alchemy be used? And maybe you could talk about like what providers you could currently support, and then like more generally what providers you think could be used with Alchemy.
Yeah, well, the answer is, like you said, any. A resource is just a create, update, delete lifecycle. That's what it is. You can do anything with that. You could scaffold coding projects if you wanted to. Create scripts could be, but like I wouldn't go that far. We support Cloudflare really strongly right now and AWS. We have some stuff for GitHub. So we have GitHub resources for managing GitHub secrets, variables, and comments. So the way that like your CI/CD posts a comment to your pull request is through Alchemy. So when you deploy Alchemy, it declares a comment resource which updates on every deploy with the preview URL, right? So there's your preview URL feature for free. So we have those. We've got Planet Scale coming. We're sort of focusing on this core of Cloudflare, Planet Scale, AWS. Stripe is another one that we'll add. Like, how quickly can you go from 0 to a payable app, right? That's operational. We've got Axiom resources. I'm deploying Axiom dashboards for Alchemy to monitor the use of our CLI. Thank you effect for the OTel integration, by the way. Like, so great. I just turned it on, and then Alchemy and then AI generated my dashboards, and I can see all the usage of all the resources. It's so good. Alchemy, I haven't implemented that feature yet, but I'm going to add just like enable OTel, and then all your infrastructure instantly gets OTel exported to where you want it, and you can just see all your dashboards, and all these things can be just like instrumented automatically for you, right? So we know the bindings, we know the connections. We just do OTel for you for free almost. So yeah, like that's the answer. Is anything you can dream of can be a provider. And if you go to the Alchemy repo and you just any coding agent say, hey, build me this resource, 5 minutes later you'll probably have it, right? It'll be tested, it'll be built, and you can just commit that to our repo.
It's very nice that the whole concept of the resource is built around the simple like CRUD like life cycle, because that means like declaring your own custom resources becomes pretty easy, which we can probably get to a little bit later. Like scaffolding out your own resources, I know is like a easy to do with Alchemy, but there are a few questions in the chat about Alchemy replacing serverless. Like there's 2 questions, one asking if Alchemy can replace serverless, and the second, is it an agnostic replacement for serverless? I think that maybe it's worth explaining to folks like the distinction here between the infrastructure and like the code for folks who've never used an IAC tool.
By serverless, do they mean serverless stack, serverless the company? Serverless could mean a lot of things. So I'm assuming the serverless like YAML stuff.
Yeah, I'm assuming that either they mean like I'm assuming that they mean like the AWS feature serverless, like but you guys can clarify to me if that's not what you folks mean, but I think that that's what they mean.
Well, remember, this is a tool for configuring infrastructure. So we're deploying a serverless worker here. Cloudflare is serverless. We just deploy it and give you a nice DX over it, right? There's also serverless stack or SST. This is a direct replacement for SST built in native TypeScript. Like SST is not TypeScript. It's just TypeScript on top of Go. This is native effect TypeScript. And one thing I didn't show, but I wasn't planning to show, but like we can just touch on it quickly, is I mentioned that effect is the best way to build, but like if you got a bunch of apps in SST or in Alchemy v1, like nothing's stopping you doing the async experience. We support that just as easily. You can just reference a worker and off it goes. You still get inferred environments, so you can deploy Lambda functions that work on SST, Pulumi, CDK. This works with all those. We're leaning hard into the effect experience because I think it's the best way to get all the way to production. But hey, pragmatism matters. Infrastructure as code should be pragmatic. You can deploy anything. Like you can deploy a Rust binary if you want to. It supports anything. Yeah.
Yeah, I think what's cool, what I really like about Alchemy, I like the fact that it's not creating a distinction between the infrastructure and the code. Like the platform that you're deploying to just becomes a part of your application. So you don't really need to think about, like, I think the problem I've always had with IAC in general is the fact that it's 2 steps. You deploy your infrastructure and then you go wherever your code is, and then you deploy your code, and you have to make sure that you did X before Y to make sure that things were done the correct way. I think what I really like about Alchemy is obviously the IAC piece and building an effect and everything like that is all super cool. But like even more simply, I just like the fact that there's no distinction between the infrastructure and the code. It all becomes like just your application, right? And I think that maybe that's what's confusing folks a little bit, especially anybody who's used an IAC tool before in the chat, is like your application and the infrastructure with Alchemy become like the same code base.
Mhm.
You don't have like a separate infrastructure. And I mean, you can have like a distinction in your code base, but like
You could
I think that maybe that's what's
you could
like,
have the separation if you want to. Like, this is separation, right? Like,
right.
think of this as your escape hatch or like your FFI call, right? Like, hey, nothing wrong with calling out to a foreign function every now and then. But like, the more you can keep in a single type-safe program where effect is protecting you, TypeScript is protecting you, Alchemy is protecting you from infrastructure, you can be sure that like even linters can help you protect you from like too many policies, right? So let me show AWS next, actually, which I think.
Yeah, maybe because this gets at another question that came up in chat right after, which was, can Alchemy replace Terraform? And I think that is a really good question. That's right on the money.
Yes, that is directly the goal. Love Terraform, great product, but like, I don't want to use Terraform, and I don't want to use tools built on Terraform. I want everything to be in TypeScript. Like, part of our goal, I tell the team, is like, hey, can 3 dudes with AI do what took $500 million to build by hand, Terraform? Can we just generate all the resources? And the answer is absolutely you can. And in fact, you can generate way better resources. You know, like, they're all built natively in Effect, and they're all built in TypeScript, and AI can just write them now. 10 years ago,
Sam,
that was a
are
bunch
you comfortable?
Huh?
Real quick, I'm getting like a bunch of questions to drop the link to your V2 website. Is it okay if I put that in the YouTube chat?
Yeah, put it in there. Just don't post it to Twitter, because I haven't fixed the OG images. They're terrible, and Twitter caches them for like 3 weeks. Don't do that.
All
There's
right,
a
chat.
tool that allows you to uncache it.
Is there? Okay, well, there you go. Post away, I guess. Yeah. Thanks. I didn't know that. Yeah.
I shared it in.
By the way, I
in
have
the
a
YouTube chat.
kind of question around the strategic choice of Alchemy. Obviously, like in infrastructure as code, you have 2 different ways to approach the same problem. One is what, for example, Terraform does, and in keeping a stateful representation of what is deployed already, and then diffing against that state. And the other way is kind of what Ansible does, where you don't have a centrally preserved state, but your deployment should check what is already deployed and what's not. I'm curious to hear generally your take on the differences between the approaches, and why you choose the stateful approach with Alchemy. And the background is, in general, I find the Ansibles easier to use, albeit more complex to implement. And I've seen nightmares where we've lost the Terraform state, and we had to, like, okay, now what do we do? The infra's code part doesn't know anymore about what exists already. Where do we go from here? And obviously,
Kubernetes is kind of the same, right? It's not a plan. It's a constantly resolved, rectified, healing system.
Yeah, it's a reconciler, basically.
Yeah, reconcile. Well, I want to support the whole reconciler thing, because that's the fastest way to deploy to Kubernetes. If you run this at Kubernetes, you're waiting for stuff you don't need to wait for, right? Like, it's just going to resolve everything. I don't have a good answer to like why planning I think is better. I think, it should support whatever it can, but like, my experience has always been this experience, I guess, is my answer to that. I don't know why Ansible is easier. If you lose your state file, you can't lose the state file. Don't lose the state file, is what I would say to that. I'll have to think about the question some more, to be honest. It's a good question that I hadn't really prepared for in my mind. I'll think about that more.
Well, I'm here for hard questions.
Yeah. I'm leaning into like this is Terraform, like declaring infrastructure, building a plan. I think the plans have value of being able to be audited, analyzed, automatically updated. I don't think it's directly incompatible with the reconciler system. At the end of the day, you have a graph that you're deploying to a system that reconciles it. We'll have to cross that boat when we get into Kubernetes, because Kubernetes should absolutely not work in this like graph way of like deploy one, wait for it, deploy the other, wait for it. That shouldn't happen, right? Another problem that DAGs have, like the Terraform Pulumi approach, is circularity is not easy to do. Things like Ansible and Kubernetes can do circularity a lot easier, right? You just put out the references and then it reconciles. But I will say that is a problem that I've always hated in these types of engines, and Alchemy has solved that with a different lifecycle. We support circularity in our resource graph. So we can deploy everything out circular, and then it resolves it in multiple steps. So our engine is kind of a reconciler, actually. You could run that anywhere, but I'll have to think more on like, hey, why did I actually do this? I don't have the right answer to that, but like, I think you can make this work in any way you want at the end of the day. It's a declarative graph of infrastructure. How we resolve it is then pluggable and changeable.
I do think there's something to be said, Sam, about the planning aspect that you bring up. Like, I think having the ability to run a plan and see if your infrastructure is like valid before you deploy it. I think that is one guarantee that you get with Terraform that you don't get with Ansible. You're responsible for dealing with a dependency with a solution like Ansible, whereas with Terraform, as long as you manage your state file correctly, you get a dependency by default. Like, that's just how Terraform is meant to work. I mean, it's not there are exceptions to the rule, of course, but yeah, but like, that's the idea behind products like Terraform, whereas Ansible is really meant to be like, you know, a configuration management tool and an automation tool. I think that's where I kind of see the value in tools like Terraform. It's like, especially as somebody who was an extremely heavy Terraform user in previous roles, being able to plan out infrastructure, especially when you're deploying at an enormous scale, is much better than the guarantees that something like Ansible gives you, in my opinion.
It's almost the difference between a Docker container and an EC2 instance, right? It's like, sure, you can run Chef on EC2 and hope that it figures it out. But you kind of want more guarantees up front. So like this plan, the way that we've designed it is that plan of like these resources and this graph is known to TypeScript. It's known to Alchemy, and TypeScript can check it for you. Alchemy can check it for you. We can layer in compliance and auditing and requirements, all the good stuff that you would want on top of a graph engine, right? So like, and things like pricing estimations is a great one of like, hey, you're going to deploy your infrastructure, and here are the estimates for like how it will change. Having a representation of the plan is useful, and overall, I just feel nervous with reconcilers compared to some sort of plan. But it's a good question, and it caught me off guard. I'll have to think more about. Hey,
I think there could be like a world where Alchemy also has the ability to operate in more of like a in more of a configuration management approach, or a agentless config management tool kind of approach. But for the moment, like, I see an exceptionally large amount of value in the way that the direction that you've taken, because for somebody who's, again, deployed very large amounts of infrastructure, like the planning, the guarantees that you get, the control that you have over the things that are being deployed, I see an enormous amount of value in a project like this. Before we move on, there have been a bunch of really good questions that have come in, so maybe we could run through a few of them for you, Sam, and you can sort of answer them for folks.
Yeah, sure.
Hang on one second. Let me scroll up a little bit. So this one user asked, if the infrastructure and the code are the same, then they are coupled. No, is there a decoupled way to deploy the same code to multiple targets?
So two things I'd say to that. One is there's this if you need decoupling, there's a way to do decoupling. If you want like a strict boundary between the code. But also, these things are just effects, right? So I could take this code here, and I could just replace this with and mostly I just have to swap out a few bindings, right? So like I have these layers down here. You just provide a different layer for how to interact with R2 in AWS, And now you have basically a generalized piece of compute. Like here's a service, and I can run this in AWS Lambda or workers, and Alchemy underneath will actually figure out how to wire that up. So if you're deploying to AWS, it'll create an IAM role, make sure that the Lambda function has access to that, and then can access Cloudflare via API. So that's a way of decoupling, is layers, right? How do we decouple in effect? Is layers. So I'll pull up my landing page here because I got one example. Is you can sort of watch this oscillate. This is components of infrastructure, right? So it's going to swap between D1 and DynamoDB. And you can see here that you can write code against an ordinary effect service, right? Context.service. And swap that out, and then it encapsulates the infrastructure requirements. So here we're using Dynamo, and in the other one we're using D1, right? But the user's code that you write could be totally abstract of what infrastructure it's running under, right? So the answer to that is the same thing we would do with effect, right?
You can almost like code your infrastructure to an interface, or you can code your infrastructure to an interface the same way you do with your applications in effect. Like the infrastructure just becomes like, you could abstract things into interfaces and like provide your concrete implementations just like you do with your normal effect programs, but now you're operating on the level of like infrastructure as well.
That's right. Yep. And these things can have all sorts, like not just like method calls. I could talk about syncs and event sources. Like they can do very interesting things. One example that we have of this is BetterAuth. So like we have a BetterAuth service here that you can use, and then we have one implementation, which is D1, right? So you can just bring that in. You're running on Cloudflare, you grab the D1 layer, and you now have BetterAuth in your app with D1. Or if you're in AWS, pick Dynamo or whatever, right? Like a totally different way of distributing components of services, not just components of infrastructure, like the business logic and the infrastructure together as a layer. So there's different layers to decoupling, right? There's decoupling out of effect. That's what where is it? That's what this is for, decoupling out of effect. Hey, like effect is great, I want to use it, but every now and then I need my own little async worker to do something little. So that's how I escape out of that. And then, hey, if I'm in effect, using context service and layers to decouple from specific infrastructure details is how to do that.
Makes sense. There was another question about, where is it? Has Cloudflare given you any incentives to focus on them? Sorry for the non-code question. Like what made you choose Cloudflare first, I guess, as a target?
Well, if you go to the website to AWS, you'll very quickly find the incentive. It's in general, like it's just a better platform, especially if you're a TypeScript serverless guy. It's so much faster to deploy to Cloudflare. Cloudflare cold start is so much lower. Durable objects, there's just no, I know like there are people building durable object like stuff, but on Cloudflare, it's just insane. Like I can have durable objects all over the world with WebSockets, and they're near my user, and I just write this simple little JavaScript. So the incentive is honestly the platform, although I really despise their API, and I hate that they don't have IAM policies and proper permissions. Like they're so good at like the front end, and then like the back end is where they drop it. But like we work closely with them. They have a really good team. I think they're a really young, vibrant team, and AWS is more like, I might as well go talk to Chase Bank to get something done. If I'm trying to work with AWS, Cloudflare, they're actually trying to make a good platform. So yeah, there's no kickback or anything from them. It's just simply a very, very good platform for what I'm trying to do.
Funny enough, to me, this could be what makes Cloudflare usable from my own perspective.
Yeah.
Because I was chatting with Dane I think a month ago, and I was basically telling him I feel like Cloudflare has the perfect infrastructure and the worst possible developer experience. But fixing the developer experience is obviously achievable, much easier than fixing the infrastructure. And like what I've seen so far is something I would use. I don't need to read the Cloudflare documentation. I just need to know that the primitives
100%.
exist and like be guided by the TypeScript type system and so on and so forth. So
Yeah.
definitely a nice achievement.
Yeah, they've gone too far. Wrangler has sort of invaded. Like, if I was to give Cloudflare feedback, it's like you need to transform into an API-oriented company, not a CLI-oriented company. Because
I had 2 feedbacks from them.
Yeah.
Kill Wrangler, kill Workerd. Just use a proper JavaScript runtime.
Yeah, Workerd.
Yeah, I told them to buy Alchemy a few times by now.
Yep.
Workerd, I have a love-hate relationship with, but I totally understand. Yeah, like, it'd be cool if it was Bun or just Node, but I think they have their reasons, their security reasons. Is that fair? I can't really remember, but you're right. But we pay for
obviously they started with Workerd at the edge, where if you recall, like years ago, it was just a way of executing some small functions at the edge to like routing and stuff like that. So for that use case, yes, it was a good thing. But then I feel like they've abused the primitive a little bit too much.
Yeah.
And like running a normal program in Workerd is painful. Like I was trying to connect to a Postgres. It's like I cannot use C bindings, and it's like, oh, like this is a wholly different thing, and I don't want to use I want to use plain JavaScript. And yes, okay, Node is not the standard JavaScript. One might argue that JavaScript is only what the engine provides, but then like I'm too used to normal JavaScript runtimes.
Well, hopefully you just become used to Effect platform, and everything just works in. Like I want to run this in the browser.
Yes,
it'd be possible, right? Yeah. I was gonna say something there. But like you're totally right. But also, I just love how it's the only serverless platform that really supports streams properly. But what you can do with streams, you can just pass them around and they work on the edge. If you've ever used AWS Lambda, they get serialized. It's like it's just not the same experience. Like you can build S3 here, just one worker grabs a stream, throws it at the bucket, and it's all natively handled. So there's some really cool stuff. If you could build Cloudflare that was Bun, man, maybe we should figure out how to do that. I would love that. So it'd be cool. All right, how am I going on time? Should I try and show some AWS stuff, or should we answer some more questions?
There's a few more questions we could probably get through quickly, and then we can look at some AWS stuff as well. But one of the questions was curious to hear how Alchemy differs from CDK. For example, CDK cannot build assets in parallel due to the way it builds the graph. How does Alchemy handle this?
Yeah, so CDK, man, I could talk about CDK. Unfortunately, leaned into constructors and synchronous code, and worst case, CJS, not even ESM, right? And also it's generating CloudFormation. So it's basically a tool chain on top of CloudFormation. It's going to generate the templates, and it'll run some assets. And you're right, it uses synchronous IO everywhere, which is a travesty. Well, you're looking at Alchemy, it's Effect. We use Effect everywhere. We use Effect for concurrency, for retries, for everything. Everything is run in parallel. Everything is optimized. Like the whole point is IAC should not be slow, right? It should be really, really fast. So Alchemy has by far the fastest infrastructure as code engine. From startup time to deployment, the slowest thing is just getting your credentials from AWS. Everything else is just like instant bun speed. But like we're different because we're not generating a template for a service that does the deployment. And then that service is doing it and you're sitting here going, what do I do? It's just a program you're running, right? It's just an Effect program that you're providing some layers to and running. That's the difference. So I can run it in plan, I can run it in destroy, and then everything runs in parallel, and we know the connection between the graph. So everything runs in graph order, right? And there's also some lifecycle things like pre-create that allows things to run out of order so that you can do like builds and things like that ahead of time and cache those so that way everything can run massively in parallel. So the answer is like, we're just a TypeScript program and we're extremely fast, and it's not a service, it's a tool chain. Yep.
Cool. Maybe one more question. 2 more questions. One, how easy is it to migrate from Terraform to Alchemy?
Good question. So like we have a feature called adoption, which means if I'm trying to create a resource, it doesn't exist in state, but it exists in the cloud. Is if the provider runs into that and you've opted into adoption, it'll pick it up, right? So that's one easy way to just be like, deploy all this infrastructure again. If it exists, just pick it up and take it off.
So is that like almost like for the Terraformers among us, is that almost like a Terraform import, except it does it automatically?
Yeah, I guess it might not be as explicit as that of like, hey, go import that from there. I don't really know what Terraform is. I'm assuming it's importing from state, or is it just importing from an existing resource?
Terraform import is like you have a particular resource that's already deployed, and you want to import it into the state file so that now it becomes tracked.
Yeah, it's like that, except it's a little bit more just like free flowing. It's like, hey, here's Alchemy at the end of the day is here's my desired infrastructure state. Deploy it for me. And if it runs into an existing and adoption's off, fail. If it's on, pick it up and take it over. So yeah, that's import. It's just not, we do also have the ability to sync as well, which is probably the similar thing. It's like, hey, there's been drift in my state, go reconcile and bring everything back into the state store. But I'm pretty sure if we had all the resources, you could just throw this in a coding agent and it would just rewrite it in Alchemy for you. We're probably missing some resources, so let us know if there's missing resources. We can spin them up pretty quickly.
And then one last question from the chat, and then I actually have a question. The question from the chat is, how do you monetize Alchemy? Paid support, something else? Question mark.
Good question. Things we're looking at, I don't have the answer, but things we're looking at is when you're working with lots of clouds, there's always the problem of secrets and profiles, and how do I manage those, and how does someone come and onboard and access secrets? And we use something like Doppler, and there's also GitHub secrets. So like secrets manager that's aware of, it's integrated directly into Alchemy, like our state stores, is something that I'm interested in. Standard stuff like dashboards. I want to build my own observability service. I'm using Axiom right now, but I think I can build a way cooler one on top of Cloudflare, durable objects. And I did the math and it's pretty cost effective. So super awesome observability that's better than Axiom, that's integrated in Alchemy aware. I think it could be cool. It's like leaning into OTel and the graph as a way to drive observability more streamlined. I also have some pretty crazy ideas I've been talking to with friends, like X402 cloud, like a accountless cloud. Just use any cloud provider, never create an account. Something like that would be really cool. I've got some friends who've bashed that idea around a few times. So exploring things like that would be a pretty radical idea. But I think there's a safe observability, account management, state management story with dashboards, and that could be worth selling. Beyond that, I don't know. I'm also tempted to just start ripping and building services. Unfortunately, I always build them as NPM packages. Like the thing about Alchemy when it comes to monetization is everything can be a library now, like everything, so you got to find a service that adds value by being managed, not just takes money because it is managed and we don't make it easy to deploy. It has to add value. So I think observability could be one of those. I think anything to do with payments could be another one. We're like open to ideas, help me out. I'm mostly focused on, can I build the best product right now? And then from there, and a user base will come a business. Yeah.
Nice.
Is the friend that is bugging you about X402?
Yes.
Our common friend?
Yes, it is. Yes. It's two friends actually, but yeah, there's I know who you're talking about. Yeah. Shout out to Harry. Yeah.
Exactly. Harry's always.
Yeah. Cool, because accounts are annoying, right? Just like we're building resources for managing AWS accounts and organizations. And I think that's really cool for like building out networks of cloud resources. But get rid of the account. Just let me use the cloud. Like a real cloud should just be there, right? It should just exist. But yeah. Anyway, that's sort of my thoughts in that department.
The question that I had was, obviously, as somebody who did DevOps for a long time professionally, I see like an enormous number of applications for this type of library or platform or whatever. How difficult is it to generate your own resources for a given provider with Alchemy? And maybe like you could show us an example of like what that looks like.
Sure. Let me load up the Discord actually, because I did one while I was preparing for this demo. Someone came in and was like, "Hey, D1 is missing some shit." So on the side I just got AI to do it. So I'll pull that up. Of course, Discord has the worst UI in the world. Here we go. Come on.
It's a race between Zoom and Discord.
Yeah. Oh no, actually, I saw you post about Rippling. Rippling is the worst product.
Yeah.
Yeah. Yeah. So where is it? Ray, where are you? Ray came in and was like, "Hey, missing features in D1. Can we get those added?" I was like, "Sure." And then like, what was it? 40 minutes later, pull request with D1 migrations and imports and clones all built, and sort of just like bang, there's your.
And maybe like, is there a particular prompt you could feed into an agent to tell it about building a like resource that you're interested in? So like,
Build me,
you're interested.
Enter.
Build this resource and look at the Alchemy docs, and that's good enough.
No, don't even look at the Alchemy docs. Just build me the whoops, wrong repo. Just come in here. We've already got an agents MD that basically briefs it on what to do. I can walk through a resource, but like it should just be self-service, right? Like someone recently added. Let's see, it's still here. Yeah, someone just threw in planet scale. There's planet scale resources, right? Like this person, I don't even really knows how Alchemy works fully, right? But the examples that are already in there are so pattern based. The great thing about infrastructure as code, it's the same problem a million times. It's not like, oh, this resource is this interface, and it's like there's properties, outputs, and a resource lifecycle, and they all look the same. And you should use
it's like create, read, delete.
Yeah, well, a little bit more. But yeah, basically, provider.
While you're pulling up the provider, maybe you could also include in your response, like these are obviously things that are included in like the Alchemy packages, right? But like imagine you have the desire to create a resource for your own internal things, or maybe you want to create a resource and not wait for it to be upstreamed. Like what would you point your agent at? Just the Alchemy agents file, or is there like?
The way that I'm designing this is like you can sort of see there's this branching tutorial, right? And then there's like reference guides, and it gets sort of deeper. We'll just have do I even have one? Let's see, guides. Pretty sure I had one somewhere. Provider. I'll create a guide specifically for it that you just throw in your agent, right? And that tells it how to navigate our website, but also trying to get more things into node modules so it can grep around in the code base. Or like, is it a Git submodule, or is it just in node modules we package all the examples or the code? Like it should just like less is more kind of thing. We give you a page, it's a jumping off point into the information network, and then AI could crawl that and find what it wants to build it. So you can just like I'll show a little example of a resource maybe. We'll pick a simple one. Let's go with GitHub comment. Right, so like you would just do this in your code base. It doesn't need to be an Alchemy code base. Like this is why it's so good to just be perfect TypeScript. There's no Terraform to worry about with their custom plugin system and blah blah. Just write a file. You declare your properties, whatever they are. These are your inputs. You declare an interface. So we have there's sort of like multiple type arguments, but basically they're all necessary to sort of declare, hey, I need these providers. I need. The reason why I have this providers is because there ended up being like 1,000 providers and the effect requirements just blows up. So I invented like a concept of collection just to reduce it down to I need Cloudflare rather than I need one of these 10,000 resources, right? Declare that, bang, create your resource, very similar to like a tag. And then I need to figure out bundling. I've got this annoying closure thing, but then you just do like a layer.effect, provider.succeed, or provider.effect. And that works exactly as you would expect it to. I'll show a different one, which would be AWS, because the more interesting is it's just a layer. So declare your dependencies, return the implementation of the CRUD lifecycle. So I go down here. Like obviously use AI for this. Like look how much stuff it needs to do. Where is return? Oh my god. Okay. And then you return how to read it. So you need a lifecycle handler for reading state. This is used for synchronization. You can implement custom diff logic. So that's what determines whether something should be replaced or whether something can be skipped. So you can override that logic. We use that to skip expensive builds and things like that. And then you implement create, update, delete, etc. Right. So one thing I want to call out here, and it was going to flow off my AWS demo, but I think we're kind of out of time, is this whole thing's built on top of what another project we have called Distilled. And Distilled is just a collection of effect native SDKs for every cloud provider you can think of. We have a bunch, as you can see, AWS, Axiom, Azure. Like we have fully automated the pipeline of go from someone else's spec to an effect native SDK that's clean, that's got tagged errors and retry, like it's effect, right? And then from there to provider. So if you had something completely archaic, you could just come to Distilled, generate an SDK, go to Alchemy, generate the providers, right? Yeah,
we're not out of time, by the way. Like we usually go until we're done. So if you want to do your AWS demo, feel free. Like we have time.
Yeah. So one thing I just want to call out here is cloud. Like we need to get effect into every cloud provider because for some reason people can't think of anything but the happy path. It's like a disease. Like AWS is the best at it, but AWS is the closest to having well errors, but even they're not good. Cloudflare has no errors documented in their spec at all. So this process doesn't just generate it from the spec, it also uses AI to patch the errors. So you get any missing error, it sets up tests for and will give you this nice experience. That way, because this is so important for infrastructure as code, right? If you're generating a resource, you need to know what errors. The errors matter so much more than the successful path, right? I don't have to teach you guys that, but like that is what Distilled is meant to solve. It's like, hey, give me effect native SDKs with patched errors. That's what Distilled is. Okay, so let's try put that back and see if I can get back on track for AWS. So let's just set up, I'm just gonna like copy a page and be like, let's set up an AWS Lambda function that gets and puts to an S3 bucket. See this and see, probably don't need this one, but see that. Okay. So AWS is a little different than Cloudflare. You still hear that I'm binding the bucket, I'm binding the durable object. And by doing that, I get access to get, set, delete, list, all those things, right? That's because Cloudflare doesn't have a good story for permissions. You just cannot restrict access to a binding. It just has access to everything, right? AWS, if you're familiar, is totally different, right? It has granular IAM policies, which is the thing I've been obsessed with forever, which is how can we automate policies because everyone forgets them? And how can we make the type system guarantee that we have the right policies? And how do we guarantee that they're least privilege or as close to least privilege as possible? That's what I've been working on for like a very long time. And effect requirements is what sort of unlocked a whole new exploration there. But in AWS, we can actually bind each of the individual methods, right? So this will map directly to, what is it? S3 get item policy, right? And this is S3 put item policy, right? And if I come and wire this up, I'll probably need to just do SSO 1 sec because my timeout is low, and make sure that Alchemy update it. Yep, so here we go. I've added in AWS and Cloudflare. So I just merge the providers. AI knows to do it, but like to your question before of like, what if I want to use 2 clouds? This is how. And now if I run deploy, you'll notice that the bindings look a little bit different these are policies now. So the bindings are individual, and you can wrap these up in an effect and give me a read access one. But the point is, we should be writing least privilege policies that are guaranteed by the type system so we can deploy compliant production-ready apps. In AWS, we take advantage of that by allowing you to sort of do these individual bindings.
So I'm assuming if you try to use like put object or something like that in an effect that doesn't have the policy provided, you get some type error?
Oh, you just won't be able to. Like this gives you the method.
Oh, that's cool.
Yeah, and you have to provide these layers. So each of these things come with layers. So that's how you plug in different environments. Like, give me the layer for AWS, give me the layer for EC2. So let me show one more example, and then I'll call it done. Which is, let's do in the same worker, show me a queue. Subscribe to the bucket events and sync them to an SQS queue. So this is the last feature, which is event sources. So I'll just give it this as well, just to be careful because we're at the end of the demo. So yeah, you can see here, like, we're catching the tag. This is the value of distilled. There's all these errors bubble up, and now you can write, like, what good is an effect SDK if you don't have tagged errors? Like, you need retries. So that's what we're solving there. So the last thing is, like, okay, cool. These are all APIs, right? Like, the request is coming into the worker, it's coming into the function, it's handling it. What about stuff in the background? Asynchronous stuff, right? Like, every time an object is written to S3, run this code, right? So the way that we do that is just with effect streams. So I can, in my initialization, I can set up this asynchronous job. It's an event source. In Lambda, it's going to be implemented with Lambda event sources. If you deploy into ECS, it'll do a polling job, right? So the layer, you swap it out with the one for EC2, it's polling. Swap it out with the one that's for Lambda, it's just a native Lambda event source. But to that question of coupling before, this is another form of decoupling. This can work in EC2 and Lambda. You can't write code like that without this, right? So you can see that we have some new bindings, right? We've got an SQSQ resource. I created a sync. So this gives me the ability to send message batch. And it also implements the sync, the effect sync for SQS using distilled SDK. And then I get this effect stream of the bucket notification. All types say, do something with it, stream.run to the sync. There you go. You got all your policies and you got everything working with effect, and it should be nice and concurrent and type safe. And yeah, so I'll leave it there. That's my demo for now. Like, I can take it further all the way through. Local dev is coming soon, so we don't have the sort of local emulation. So deploying to the cloud, but running things locally, so you can iterate on a website. We've also got, you can just go straight to CI/CD. This will set up deploying preview environments of all your infrastructure in GitHub, and then tearing it down when you merge the PR. And we've got Vite websites. Like, you can just deploy any Vite website to Cloudflare, like, instantly. 10 stack start, or you can deploy Astro, whatever. So, like, there's a lot more here, but I wanted to show the core of how effect can revolutionize infrastructure and building apps and I think this is directly, I can't imagine trying to teach this to people like 2 years ago, but with AI, it's like, we almost don't need to teach anything anymore, right? We just need to teach the AI. I think the potential for, like, these vertically integrated experiences is, like, more than ever before. Like, we can build specifically for AI as a user. And that's what we're trying to do with Alchemy. Yeah.
I'm curious, sorry, what is your local setup in this Cursor project? Because it seems like everything works out of the box, and it's a very good experience. Are you using skills, or how are you structuring the repo?
There's no like this. Like, this is all driven by bun. This was bun init -yes, and that link that I posted in at the top. This button here. I don't use skills. I don't know if I like skills. I kind of like just, like, grabbing information when you need it. I think I prefer things to be in NPM packages. So I think I want to just, the website should be markdown native and crawlable very easily. And then node modules should be greppable. and then it can just find everything it needs. And then there's no syncing problem, like you're using the version that you're using. So there's no setup here. It's just coding agents are that good now. You can just give it a page and it can do it. Yeah.
That's great.
There was one question in chat, which I think that somebody already answered, but I'll raise it up to the stream so that other folks can hear the answer. But the question was, so in Alchemy, if I read from DynamoDB, for example, it will only add read policies. And when I start writing to it, it will automatically only add the write policies as well. If yes, then that is very cool.
Yes, it naturally flows, right? Like in order to write, I must declare write dependency, get the function, and then call write. And like language models think in that order. They always go from top to bottom. I don't know if you've ever noticed this, but they write utilities at the top of the file. And I hate that. And then they write the actual thing. It's because LLMs think in that direction. So like this is designed to be like, oh, I want to do this. So I add that at the top and then I use it. Bind, use, That's the pattern. Yeah, so the policies just emerge from the building of the app, right? The bindings and the policies all just emerge naturally. You don't have to like teach AI. First, you must add this over here and make sure you do an environment variable, and then go over here and grab the environment variable and create an SDK, and then go over here. You don't do that. It's just linear flow through your code. Yeah.
It's funny because I think we have discussed the way of deriving policies for months. And,
yeah, I went down a deep rabbit hole.
Yeah, I think you went down a pretty deep rabbit hole in trying to do the reverse.
Yeah, I did.
And
I'm glad I did.
So nice to.
Yeah. The lesson there.
I mean, rabbit holes, of course.
The lesson there is encapsulation matters. That's what I found out. Is like I was trying to do it the reverse of you just use the bucket and then you provide the policy as a layer. And that was cool because my dream has always been static analysis of the code, infer IAM policies, guaranteed least privilege. And that one was guaranteed least privilege. But like, you're right, it's excessive, But the problem is they all have to bubble out. So you end up with this problem of like the dependencies of this thing, this fetch call needs to bubble out. And that breaks encapsulation. Now you can't build layers properly. You got to build all these hacks to transform the function, grab the requirements, and you can't transform generic functions in TypeScript. So it's wrong. It's just straight up wrong. I think, in a different language, maybe you could do it. But then again, the more I learned about layers, I was like, oh no, like this is perfect. Just initialize the layer, return the implementation. That pattern is composable naturally, very easy to write, and gives you pragmatic guarantees around your policies. And that's perfect. That's great.
We call it the constructor pattern or the service pattern.
I've been looking for a new name. I don't have a good name. I call it initial. I've got init and plan time. I think I might go with constructor pattern. That's good. Yeah.
A layer is really just like an effectful constructor at the end of the day that can have dependencies. So
I was also calling it a higher order effect. I don't know if that's a thing. It's an effect that returns an effect. I use that a lot. Like effects that return effects are very powerful. Yeah.
I think it's easier to grok. I mean, it's a layer is an effectful constructor. It's like a thing that's like, when I try to explain it to people, it makes it a little bit easier for them to understand. But
yeah, but it's not as cool, right?
Higher order effects.
Higher order effects. Cool.
This isn't React, bro.
Yeah.
Like higher order functions, just functions.
Yeah.
Just functions.
You're right.
There was one question that I want to close with, which is there a concept of environments similar to SST in Alchemy?
Oh yeah, there's stages, right? So this is just using the default stage. So the default stage is your username, right? It's just like dev_username, but you can do stage prod here, and that'll give us a clean state. Goddamn AWS is slow. So that's a new environment, right? So like, for example, pull requests. Let me pull up the docs.
And maybe you could also show how, if possible, you can use the stage inside the program as well.
Oh yeah, sure. There it is right there. you can just yield star stack. It's an effects service, and every stack and resource can access that, and on it is stage, stack name, and some other metadata. So you can just grab that. I sort of skipped over that in the Lambda one. Let me show you that. For example, in Lambda, you might want to tune the memory for prod differently than dev, right? But in order to get this to be a function that can be bundled and run somewhere, I have to export default, right? I can't have a function. I can't call it with arguments. So the way we plumb that through is effect service, right? So the properties of a resource can also be an effect. And then through that, you can grab requirements like the stack. And here I'm tuning the memory, giving it more memory in prod, for example, or pick a different instance type in prod, or pick a different instance type in the US East region. All plumbed through with effect context. One thing I'd like to mention actually is I've been trying to build something like this for maybe like 5-6 years, and it's kind of crazy. And I built one on CDK. It was called Punch Card, and it was runtime and infrastructure code all together, right? A long time ago. But it had the problem of like, I want to deploy my app. I don't want to deploy the app with all the CDK code in the bundle, right? So my bundle was like 30 megabytes, 50 megabytes, something crazy. Effect context finally allows me to build infrastructure that is aware of all the resource providers, but they don't end up in the bundle. It's so cool. Like, because we provide the layers here, this is the heavy code. This is going to be like, megabytes and megabytes. But your application code is just declaring a queue here. This queue is nothing. It's just a data structure. It's just an effect with the data structure. So that unlocking, the decoupling that layers give us is what is allowing us to build what is technically almost like a cloud programming language. People have tried it before, and they build special syntax in different language, or they build bundling hacks on top of existing TypeScript. And I've done all that. Effect has solved it like in one go. Just layers give you decoupling, and you can just sort of layer, and you get infrastructure containing runtime code, and it all flows, and it's all tree shake optimal. I just want to call that out.
What is the build process? Do you just strip out those things and like? It's obviously here code is fused with.
So this is just roll down, and like the provider. So if I go to the queue does nothing. It's just a data structure, and then this is the provider code. You can see why I've got this closure here. I'm trying to figure out how to do this with a roll down plugin. Like there is a way to do it, and I have.
We have a roll down plugin. You can just copy it. I
did. I copied it the other day. I'm working on it. It doubled the bundle time, unfortunately, but like you could also just add an arrow function and type, and roll down knows this is pure, and it will tree shake it away. So yeah, the answer is no magic. Just basic roll down bundling, and maybe a plugin. Because side effects false means nothing, apparently. Yeah.
But if it did double your bundle time, tell it to Sebastian, because I feel like he has built the plugin, and most likely there's like room for optimization in.
Oh yeah, I skipped that step, and I just told Claude. No, we should seek actually. Maybe we can put it out as a package, like a pure plugin for roll down would be cool. Like we were thinking,
nerd sniping Sebastian is so much more fun than nerd sniping Claude.
Yeah, you're right. I'm just
plus it's free inference.
Free inference.
The agency of AI.
Yeah,
I would love
free inference.
For anybody who wants to see Sam's or learn more about Sam's journey, by the way, getting to this point with Alchemy, there's a really great conversation that was had between Sam, James Ward, and Bruce Eckel on the Happy Path Programming podcast several months ago now, where you kind of like walked them through your journey up until this point.
Mm-hmm.
And I enjoyed that episode of their podcast very much, but I think it's on YouTube now for anybody who's curious. But anyway, look that up if anybody's curious.
I'd love to go on there again and talk about it, because I showed the old rabbit hole in that podcast, and now I have the better version. So maybe it's time for a V2. But yeah, thanks for calling that out.
Yeah, shout out to James and Bruce. They're good. They have a great podcast.
Mm-hmm.
All right. I think that we've answered pretty much everybody's questions. So I'll take this moment to thank Sam for your time very much, for coming on and chatting with us and showing off Alchemy and showing what effects can do for infrastructure as code, or maybe just infrastructure as effects. If anybody's curious about Alchemy, make sure you join the Alchemy Discord, which maybe we can put in the office hours chat for folks who want to join in our Discord. And also make sure you go to the Alchemy website to learn more about Alchemy, and start using it and giving feedback, because I'm sure Sam and the team are looking for people to use Alchemy and provide feedback. But yeah, Sam, thank you very much for your time today. Thank you for sharing all the work you folks have been doing.
Yeah, thanks. Thanks for Effect. It's awesome.
All right, cheers, folks. Until next office hours. I think next week we may be taking the week off because we have a team offsite, or maybe we'll just all sit in the room and chat together. Who knows? But if we don't see you next week, we'll be back the following week with office hours again. So until then, cheers, folks.
We could do a pool-based office hours. We all sit in the pool.
Sitting next to the pool.
In the pool, inside.
In the pool.
I'm not taking my new MacBook in the pool. All right, folks. Have a good one. Cheers, everyone.